Hello, so I got this question from my math lab. We are working with the central limit theorem here, and in this problem it looks like we are given some weights for men, and we're told that the design weights were for men, but we're told that the weights of women are normally distributed. That means we can use z-scores for the weights of women. They give us the mean and a standard deviation. So part one, I am actually going to adjust this, and I'm going to use StatCrunch to solve it. So I'm going to go to Stat, Calculators, Normal, and I'm going to enter in the mean and the standard deviation that they gave us. The mean was 173 and the standard deviation was 38. But this time up here, I'm going to click between, because what we're actually trying to find is the probability that the weight is between 140 and 211. So I want to go between 140 and 211, and I get a probability of 0.648, and I'll come around this to 4 decimal places. So this would round up to an 8. Perfect. So the difference in part B is here they say 28 women were randomly selected. So there's a difference between doing 1 woman and 28 women. And when you're doing 28 women, how things change is that we don't put in the standard deviation. So the central limit theorem says if you want to look at more than one person and if you want to look at the mean of more than one person of a group and your data is normally distributed, you still use the same mean, but the standard deviation that you use is the original standard deviation, but you have to divide it by the square root of your sample size. So I just said a whole bunch. I'm going to quickly calculate that. It is the original standard deviation, which was 38. But I need to divide that by the square root of our sample size, the square root of 28. And if I take 38 and divide it by the square root of 728, I get this number here. So I'm going to now put this in for my standard deviation. And we're looking for, again, the mean weight to be 140 and 211. So I'm going to keep the 140 and 211 the same. And this time I get 0.99999, which gives me 1, if I were to round that to 4 decimal places. And I am going to let you think about the problem. Let me know if you have any questions about the steps that I did, and let me know what your thoughts are for part C.